see the next method, which is present in the instrumental methods of analysis, and that is conductometric titration. So you do have this conductometric titration also for your engineering chemistry practicals. Okay, so here also we have, there also we have. So what we are going to study in this conductometric titration? What are we going to measure? So we are going to measure conductance of the solution by using an instrument called as conductometer. Okay, so instrument used, it is named as conductometer, which is going to give us the conductance values of the solution. Okay, so what is conductance? Conductance means it is reciprocal of resistance. So how can we define it? So we can define it as the ability of an ion to conduct electricity. So conductance means the ability of an ion to conduct electricity. And what is the unit of conductance? It is mho, mho, reverse of resistance, OHM. That is, ohm is resistance, conductance is reciprocal of resistance, and its unit is mho. Okay, so how do we define this conductometric titration? So I said we are going to measure the conductance of the solution. So how are we going to measure the conductance of the solution? So we are going to measure it by using the instrument called as conductometer. So by measuring the conductance values of the solution, we are going to get the end point of the solution or the reaction. The end point is nothing but the equivalence point. Okay, so how to define it? This is the titration, which involves the determination of equivalence point of the solution by the measurement of conductance of the solution. Okay, so conductometric titration is the titration in which we are going to determine the equivalence point of the solution. So how we are going to determine the equivalence point of the solution? By measuring the conductance of the solution. Okay, so this is called as conductometric titrations. Please don't write anything in the chat box with respect to your attendance. I'll be taking the attendance myself. Okay, you know, right? I'll be taking the screenshot. So please don't type anything in the chat box other than any queries if you have. Please don't mention your attendance in chat box. Okay, so how to define this conductometric titration? This is the titration which involves the determination of the equivalence point of the solution by measuring the conductance of the solution. Okay, so this is conductometric titration. So what is the theory behind this experiment? So it states that Ohm's law states that the current, that is I, is directly proportional to the applied EMF E and inversely proportional to the resistance ohm of the conductor. So I is directly proportional to E and inversely proportional to R. So Ohm's law states that the current I in amperes flowing in a conductometer is directly proportional to the applied EMF E and inversely proportional to the resistance R of the conductor. Okay, so the conductance, it is going to depend upon certain factors. So which are those certain factors? So it is going to depend upon the nature of the solution. So conductance is going to depend upon the nature of the solution. So it is going to depend upon the number of the ions present in the solutions. Okay, it is going to depend upon the number of ions which are present in the solution. And also it is going to depend upon the mobility of the ions present in the solution. So what are the factors that conductance is depending upon? It is depending upon the nature of the solution, number of the ions present in the solution, and their mobility also. So if we have the higher concentration solution, so definitely we will be having the number of ions which are present there are fast moving, are moving very fastly, then definitely the conductance will also be high. Okay, so if the concentration of the solution increases, it means that the number of ions are increasing, and if the number of ions are increasing and their mobility is increasing, or if they are fast mobile, then the conductance will also be higher. So it is directly proportional. Larger the concentration of the fast mobile ions, higher will be the conductance. And lower the concentration, lower will be the conductance. Okay, higher the concentration, higher will be the conductance. Lower the concentration, lower will be the conductance. Because the mobility of the ions, if it is fast, then conductance is high. If the mobility of the ions is slow, then conductance will be low. So what is the instrumentation? So conductometric titration, in this case, we are using a cell called as conductivity cell. So this is the conductivity cell. Okay, so what does this conductivity cell consist of? It consists of 2 platinum electrodes. Here you can see shiny plate at the bottom. Okay, so silver kind of, black kind of plates, you can see 2 plates are there here. So these are nothing but the 2 platinum electrodes. Okay, in order to make it properly observe, I have given this figure. So here we have 2 platinum plates. So these 2 are the platinum electrodes which are present in the conductivity cell. So these are going to help us in measuring the conductance. So these 2 electrodes which are there, okay, these 2 electrodes which are there, they are placed at 1 centimeter apart, or you can say unit centimeter apart, with an area of cross section of unity. So the 2 electrodes have unit area of cross section and they are placed unit distance apart. And the assembly responds rapidly to the changes in the concentration of the analyte. Analyte means test solution. So what does this conductivity cell consist of? It consists of 2 platinum electrodes at the bottom. These 2 platinum electrodes are present in an unit area of cross section with unit distance apart. And using this conductivity cell, we are going to measure the conductance of the solution using the instrument conductometer. So this is the instrumentation. So what is the setup of the experiment? So we have the beaker. In the beaker, we are going to take the sample or the solution which is to be analyzed, whose concentration is to be known, okay, or the number of the concentration or the amount of the species present in that solution is to be known. So whatever the test solution is there, that is taken in this beaker. And it is also equipped with a stirrer. Stirrer is for stirring the solution. And then dip the conductivity cell. Connect it to the conductometer. So dip the conductivity cell, which is having the 2 platinum electrodes at the bottom, and connect that to the conductometer. And from burette, you will be adding the titrant. Okay, so what all we have in this experimental setup? We have the beaker containing the test solution, and it is immersed with this conductivity cell and also equipped with the stirrer. Conductivity cell is connected to the conductometer for the displaying of the conductivity values, and this is the titrant taken in the microburette. Okay, so this is the experimental setup. So how we are going to do this experiment? So we have for your syllabus 3 kind of experiments. So all these 3 we will see one after the other. So first one is strong acid versus strong base. So if they have given us strong acid versus strong base, then how are the conductivity values going to vary, and how we are going to find the equivalence point or the end point of the reaction? So acid base means definitely it is a neutralization reaction, correct? So what is the strong acid given to us here? It is HCl. What is the strong base given to us here? It is NaOH. Okay, and what is meant by strong acid? The one which will ionize completely. And what is meant by strong base? Same. So ionize completely. What is meant by weak acid or a weak base? The one which is going to ionize partially. Okay, so in this case, we have HCl and NaOH. HCl is taken in a beaker. Okay, so I'll go to the previous slide. So in this beaker, let me take HCl. So I don't know how much HCl they have given. I don't know how much volume of HCl they have given me in that sample. We have to find that. Based on that, we can find the concentration or how many grams per liter of that HCl is present. All these things we can find. Okay, so in the beaker, I'm going to take the HCl solution, dip the stirrer, immerse the electrode, that is the conductivity cell, and in the microburette, I'll take NaOH. Okay, so NaOH is taken in burette. HCl is taken in beaker. Now what you do? Connect it to the conductivity cell, and for 0 cc of NaOH added, means I have not added anything, directly measure what is the conductivity of this HCl solution for 0 cc of NaOH added. Note down the conductivity value. Now add 0.5 cc of NaOH into this HCl, stir it properly, and the constant reading that is displayed, note down that reading. So 0.5 cc I added. Now again add 0.5 cc, note down the reading. Again add 0.5 cc, note down the reading. Again add 0.5 cc, note down the reading. So with an interval of 0.5 cc each time, go on measuring the conductivity values. Until when? Until you get back the first reading. So you can see this graph. So I got, say for example, I got first reading as something like 13 or something. So until you get back almost close to 13, not exactly 13, it may be 12.8 or 13.2, something like that, which is close to the first reading. Until then, go on carrying out the reaction by adding 0.5 cc of NaOH each time, stir the solution, note down the reading. Okay, so what kind of reaction is taking place here? Neutralization reaction is taking place. So HCl is going to get neutralized by the addition of NaOH. So what happens? So in the case of strong acid and strong base, the conductance is going to fall down, okay, due to the replacement of the highly mobile H plus ions by less mobile Na plus ions. And after the equivalence point, the conductance rapidly rises with further addition of strong base and is due to increase in the concentration of the OH minus ions. So when I plotted the graph of conductance versus volume of NaOH, I saw that initially the conductance value goes on decreasing up to a certain point. And after that point, it will go on increasing. So why this is happening? Why the conductivity value decreased first, and after a certain point, why it increased? Okay, here, HCl we have. Can I write HCl as H plus and Cl minus? Yes, I can write. NaOH we are adding it from the burette to this HCl. So NaOH I can write as Na plus and OH minus. So what is the reaction taking place? Neutralization reaction. Formation of salt is going to take place, right? So I have H plus here and I have Na plus here. On adding NaOH, so this slow moving Na plus ion is replacing the fast moving H plus ion, combines with Cl minus and forms NaCl. And this OH minus ion combines with H plus and forms the water. So what happened? The slow moving Na plus ion replaces the H plus ions, which are fast moving, and combines with Cl minus and forms NaCl. And water is formed by H plus and OH minus. So what happened to the concentration of H plus ions? So H plus ion is forming with OH minus ion as water. So H plus ion concentration went on decreasing. Number of H plus ions went on decreasing, right? With the addition of NaOH, H plus ions went on decreasing. So conductivity value will go on decreasing. So why this case we are observing the decrease in the conductivity values? It is due to the decrease in the H plus ions. Okay, so during the course of this reaction, H plus concentration went on decreasing. As the number of H plus ions went on decreasing, conductivity value will go on decreasing. Once HCl is completely neutralized, once no more H plus ions are present, once HCl is completely neutralized, so after that point, even still we are continuing the addition of NaOH, right? So I'm still adding NaOH. So NaOH I'm adding means I'm adding OH minus. So after this point, it goes on increasing due to the increase in the concentration of the OH minus ions, which I am adding in the form of NaOH. So this is due to the excess of the NaOH added. Got to know? So this point, which is there, this is the equivalence point where complete HCl got neutralized, which is the end point of the reaction. That is equivalence point of the reaction. So let me repeat. So why it decreases first? Because the decrease in the H plus ions takes place during the course of the reaction. As the number of the H plus ions decreases, the conductivity value will also decreases. And after a certain point, we are still adding NaOH. Means we are introducing OH minus ions into the solution. So this conductivity value will go on increasing due to the excess of the NaOH added. That is due to the increase in the number of the OH minus ions which are introduced into the beaker. Okay, and this point where we are observing this sharp V, so this is the end point of the reaction. That is complete neutralization took place. So this is the equivalence point. So taking this value, we can do the calculation and find the strength of this HCl given. Strength means concentration of the HCl, which was unknown to us. So using the formulas, we can do that. So this is one system where we used strong acid and strong base. I hope you all understood. Okay, so next we will go for next system. So this second system which we are studying, this is the experiment which you are going to carry out in your regular practicals. So what is that? So it is mixture of strong acid and a weak acid versus strong base. Means they are going to give you a strong acid and a weak acid mixture, and that you are going to titrate against strong base. So which is the mixture of strong acid and weak acid? So that is the mixture of HCl and acetic acid. So HCl and acetic acid together in a form of a mixture is given to you. I don't know how much HCl they have given. I don't know how much acetic acid they have given. So I have to find it. How much HCl they have given, how much acetic acid they have given, and what is the strength of HCl and what is the strength of acetic acid. How? By titrating it against strong base, that is NaOH. Okay, understood? What is the aim of the experiment? So they have given a mixture of acid. We don't know how much it is. We have to determine it. So in that mixture, how much is the strength of HCl and how much is the strength of acetic acid? How much HCl was given and how much acetic acid was given? By finding the equivalence point of the reaction, titrating it against a strong base NaOH. So this is the reaction which we have to carry out now. So what you do, in beaker, the mixture is given. So dip the stirrer, dip the conductivity cell, connect it to conductometer, and in microburette, take the NaOH. So in beaker, we have acid, and in microburette, we have NaOH. Okay. So as usual, as I said in the previous experiment, for 0 cc of NaOH added, note down the conductivity value. Then add 0.5 cc of NaOH. Stir the solution, note down the conductivity value. Again add 0.5 cc of NaOH. Note down the conductivity value. Again add 0.5 cc, note down the value. Like this, go on continuing until you get back the first reading. So you can see, right, I have got this kind of graph here. So first the readings decreases, then it will slightly increase, then it will rapidly increase. So take down the last reading until you get back the reading which is close to that of the first reading, almost near to that of the first reading. Okay, so until then you carry out the experiment. So what we observe here is initially the readings will go on decreasing, then they will slightly increase, and then they will rapidly increase. So why this is going to take place? So I have HCl and acetic acid in the mixture, and we are titrating it against NaOH. So among HCl and acetic acid, which do you think will neutralize first? Strong acid will neutralize first, or weak acid will neutralize first? Definitely strong acid will neutralize, right? So first HCl will neutralize. Once all the HCl is neutralized, then acetic acid will come into the picture. Then acetic acid will start neutralizing. Okay. So HCl I can write as H plus and Cl minus. And acetic acid I can write as CH3CO minus and H plus. And NaOH I'm adding from the burette, I can write it as Na plus and OH minus, right? Okay. So among this HCl and acetic acid, so HCl is going to neutralize first because it is the strong acid. Okay, so on adding NaOH, HCl will neutralize first. So the same thing, whatever we saw in the previous application. So the slow moving Na plus ion replaces the fast moving H plus ions, combines with Cl minus, forms NaCl plus water. So what happened in this case? The concentration of the H plus ions decreases. So the number of the H plus ion decreases on addition of NaOH. Therefore, the conductivity value will also decrease. So in this graph, you can see the values is going on decreasing It is due to the number of the H plus ions which are going to decrease during the neutralization of HCl by NaOH. Okay. Once all the HCl is neutralized, then acetic acid is also present in the mixture. Now acetic acid will come into the picture. So what reaction will take place? So acetic acid, I can write it as CH2CO minus and H plus. And we are adding Na plus and OH minus. So formation of a salt will take place here, which is a strong electrolyte. CH3CO minus combines with Na plus and forms sodium acetate. CH3CO minus Na plus, that is CH3COO Na. Sodium acetate, a strong electrolyte, a salt is formed along with water. So you can see the second line which you are seeing, slowly their readings are increasing, right? In this case, it is due to the formation of the sodium acetate, a strong electrolyte. Okay, so in this case, the formation of the sodium acetate is going to take place during the neutralization of weak acid with NaOH. So as the sodium acetate is forming, as the salt is forming, the conductivity value will go on increasing slightly. Once all the acetic acid is neutralized, we are still adding NaOH, right? Until when we are adding NaOH? Until we get back the first reading. So we are introducing excess of NaOH. So this values will go on increasing due to the excess of the OH minus ions which you are adding into the beaker. So first, why it decreases? Because H plus ions decreases. Why it increases? Because sodium acetate is formed during the neutralization of acetic acid. Why it rapidly increases at the last phase? It is due to the excess of the NaOH added. That is the excess of the OH minus which we are adding to the solution. So this is why we are going to get 3 lines here. Okay, take the intersection point here. So this is V1. Take the intersection point here. Let this be V2. Okay, so now from 0 to V1. So this point from 0 cc to V1 cc. It is the volume of the NaOH required to neutralize HCl. So this is the volume of the NaOH required to neutralize HCl. And from 0 to V2. From 0 to V2. Is it volume of NaOH required to neutralize acetic acid? No. It is the volume of NaOH required to neutralize both HCl and acetic acid. Okay. From 0 to V2 I am telling. So it is the volume of NaOH required to neutralize both HCl and acetic acid. Then how much is the volume of NaOH required to neutralize only acetic acid? It is this region. That is V2 minus V1. So V2 minus V1 is the volume of NaOH required to neutralize only acetic acid. So using this V1, which is the volume of NaOH required to neutralize HCl, and V2 minus V1, which is the volume of the NaOH required to neutralize only acetic acid, taking these values, we are going to do the calculations and find the strength of HCl and acetic acid and the given unknown acid mixture. Okay, so this is about this experiment. So did you understand? So we have HCl and acetic acid given in the form of a mixture, and it is titrating against NaOH. So each time go on adding 0, 0.51, 1.52, 2.53, 3.5, like this, go on taking the readings with an interval of 0.5 cc of NaOH added to it. Okay, so now what we see, the conductivity value will go on decreasing first, they will slightly increase, and they will rapidly increase. So why they will decrease while the conductivity value decreases in the first phase? It is due to the decrease in the H plus ions. So first HCl is going to neutralize. So when HCl is going to neutralize, so H plus ion combines with the OH minus and ions and forms water. And Na plus ions combine with Cl minus ions and form NaCl. So H plus ion concentration is decreasing here. Therefore, conductivity value will also decreases. And once all the HCl is neutralized, so this is the point where all the HCl is neutralized. Now acetic acid will come into the picture. Now acetic acid will start neutralizing. So when acetic acid reacts with NaOH, the formation of a salt is going to take place, which is a strong electrolyte. So the conductivity value will go on increasing due to the formation of the sodium acetate, a strong electrolyte, a salt. Once acetic acid is also completely neutralized, we are still adding NaOH until we get back the first reading. So we are introducing excess of OH minus ions. So as the number of OH minus ions are increasing into the solution, its conductivity value will also go on increasing. So this is about this experiment. So here V1 is the volume of the NaOH required to neutralize HCl. V2 minus V1 is the volume of the NaOH required to neutralize acetic acid. Okay. Next one. Last one. Weak acid versus strong base. So weak acid is acetic acid, which is taken in the beaker, and NaOH is taken in the microburette. Okay, the same experimental setup has to be done. So when acetic acid is titrated against NaOH, so sodium acetate is the salt which is forming with the water. So the same explanation in the previous case we saw, right? So leave this part. So this is due to the formation of sodium acetate, and this is due to the addition of excess of NaOH. So only this part will be observed in the next case, right? Here in the graph, only the second phase and the third phase, only the second line and the third line are being observed. And the explanation is same. So weak acid partially dissociates in the aqueous solution. The conductance of the acid will be initially low due to poor dissociation. When the strong base is added to the acid, the salt is formed, so which is highly ionizable, and conductance increases on complete neutralization of the acid. Further addition of the base lead to an increase in the number of the more OH minus ions, and hence conductance increases sharply. So what it says, so initially as it is a weak acid, it partially dissociates, and conductance of the acid is little bit poor because of the poor dissociation. But when we add NaOH to acetic acid, a salt is formed which is ionizable, that is sodium acetate can ionize into Na plus and CH2CO minus, and hence the formation of this salt, the conductivity value will go on increasing slightly, and once the acetic acid is completely neutralized, as we are further adding NaOH, so the increase in the OH minus ions takes place in the mixture, hence the values of the conductivity will go on increasing. So this is due to the formation of the strong electrolyte, and this is due to the addition of the excess of NaOH, that is introducing OH minus ions into the solution. So this is the explanation of this third case. Next, advantages. So what are the advantages of this method? So we can find the strength of the acids even if they are in the form of the mixture. So even if the mixture of acids are given, they can be titrated, and their strength can be determined by titrating it against the suitable titrant. And even the dilute solutions will give us the accurate readings. So even we can test this for the dilute solutions. And actually, in case of potentiometry, it becomes difficult to titrate the very, very weak acids. But in case of conductometry, we can study the weak acids also. Okay, so these are the advantages of conductometric titrations. Okay, so what all we saw today? So what is conductance? It is the ability of an ion to conduct electricity. It is reciprocal of resistance. So what is meant by conductometric titration? It means that we are going to measure the conductance of the solution through which we will get the equivalence point. So that is conductometric titration. And what is the theory? Current is directly proportional to EMF and inversely proportional to resistance. And conductance value of the electrolytic solution depends upon nature of the solution, number of the ions present in the solution, and mobility of the ions present in the solution. So larger the concentration, more will be the fast moving ions, then higher will be the conductance. Lower the concentration, if less mobile ions, then lesser will be the conductance. Okay, and what does the instrumentation setup consist of? It consists of a conductometer to which a conductivity cell is attached. And in conductivity cell, we have the two platinum electrodes So which are placed at unit distance apart in an unit area of cross section. And we have a beaker which is containing the test solution with a stirrer, equipped with a stirrer for the proper dissolution of the solution. And the titrant is taken in this microburette. So this is the instrumentation. And the first case application, we have strong acid versus strong base. So in case of strong acid versus strong base, we have taken HCl versus NaOH, and we see that initially the conductance value decreases and later it will increase. So why it decreases? As the NaOH is added, so it combines with the H plus ions, that is OH minus ions combines with the H plus ions, forms water. Na plus ions combines with the Cl minus ions and forms NaCl. And as the H plus ion concentration is decreasing, as the number of the H plus ions is decreasing, the conductivity value will also decreases. Once complete HCl is neutralized, as we are still adding or introducing OH minus ions into the solutions, with the excess of the NaOH added, the conductivity value will go on increasing. And if we have given a mixture of the strong acid and a weak acid, along with the base, that is, we have a mixture of acid consisting of HCl and acetic acid against NaOH, we see that initially the conductivity value decreases and then they will slightly increase and then they will rapidly increase. So why it decreases initially? Because first HCl is going to dissociate. Being a strong acid, first HCl is going to undergo neutralization. So due to the decrease in the H plus ions, the conductivity value will decrease. Once all the HCl is neutralized, then acetic acid will come into the picture. When acetic acid will react with NaOH, we get sodium acetate, and the value will go on increasing slightly. It is due to the formation of the sodium acetate, a strong electrolyte. And once all the acetic acid is also neutralized completely, we are still introducing NaOH. Therefore, the conductivity value will go on increasing due to the increase in the OH minus ions. And the last one is weak acid versus strong base. So that is acetic acid is taken in beaker and NaOH is added as a titrant from the microburette. So we see that as acetic acid is a weak acid, it is going to dissociate partially or the poor dissociation takes place. But on addition of NaOH, a strong electrolyte is formed. So sodium acetate, a strong electrolyte is formed, which is ionizable. Therefore, the values will go on increasing slightly. Once the acetic acid is completely neutralized, we are still adding NaOH. So we are adding OH minus ions in excess, hence the conductivity value will increases in this case. So these are the three different cases. And what are the advantages? We can study it for mixture of acids, we can study it for the dilute solutions, we can study it for the very weak acids also. So this is all about conductometric titration. Any doubts? Did you all understand?